All right, so we have our final video of 2.3. The objective is to graph a linear equation. We're given our equation negative 2x plus y equals 1. And what we have to do is kind of think about what do we need to know in order to graph this accurately. So we could have 2 points. There's a number of different ways we can go with this, but I think through this section we've seen so far that we've used slope-intercept to identify slope and to identify the y-intercept. As long as we have a single point and we have slope, then we can graph the line accurately. So in this case, what we're going to do is we're going to convert from standard form into slope-intercept form. It's actually a little modified from standard form, but we're going to take this into slope-intercept form. We're going to pull the y-intercept out, use that, and then we're going to pull the slope out and use that. So our first step here, we're going to take the negative 2x and it's going to move across the equal sign. All right, so remember now, the reason the 2x comes first, y equals mx plus b, we put it in the form so that we can just pull our slope out and our y-intercept out. We're going to start with our y-intercept because that's the way we need to start on a graph. So in this case, our y-intercept b is going to be 1, and we also have to remember that that's the point 0, 1. All right, so we're talking about a y-intercept. Here's our y-axis. So from the origin, I'm going to count up 1. And I'm going to plot that point. So that point, it's just a starting point on the graph. It could have been any point. In this case, it happens to be the y-intercept. So that's where we're going to start from. The next thing we need then would be the slope. So in this case, my slope is the coefficient on the x. So we're going to have a slope of 2. So the thing is about slope, remember, it's rise over run. So if I have a fraction, it works out really, really nicely. In this case, I don't have a fraction, so what I want to do is write it as a fraction. So 2 over 1, and I'm just going to make a note, this is rise over run. So rise, if I'm rising a positive number, I'm going up. If I were rising a negative number, I would be going down. If I'm running a positive number, I would go right, and if I'm running a negative number, I would go left. So in this case, I've got a rise of 2. So from my y-intercept, I'm going to count up 2, and then I have a run of 1, so I'm going to count to the right 1. Now I can continue that process and get multiple points for this graph. So I can go up 2, right 1, up 2, right 1, and I could continue that. If for some reason I needed to go in the other direction, I have to reverse everything. So instead of up, I'm going to go down. Instead of right, I'm going to go left. So we're going to go down to left 1, and you notice that that lines up right with all the other points there. So darken that in so you can see it. All right, so now I'm going to continue down 2 and left 1, down 2 and left 1. I did a little exploration trying to find a yardstick and couldn't find one, unfortunately, so I'm going to draw this in by hand. Now, you guys use a straight edge. Any straight edge will work. Your ID is usually great. It's about the perfect size. So just, I'm going to sketch it in. I apologize for that. And you can see it gets a little rough on the ends there, so I apologize. So this was graphing the equation of a line, and big key, put it in slope-intercept form. You can take the slope out, you can take the y-intercept out. We always plot the y-intercept first and then count the slope to get adjoining points.